Hello everyone, and welcome back to Dr. Liu's VCE Physical channel. Think a constant speed always means an inertial frame. Or that calculating gamma is just a simple division. Think again. Over 40% of VCE physics students drop marks on these exact special relativity questions because of simple, hidden traps. In this video, we are breaking down the official examiner reports to show you the exact words that secure full marks, and how to never swap your proper and dilated variables again. Ignoring the motion of Earth, which one of the following travelers is not in an inertial frame of reference? Core principle. Definition: an inertial frame of reference is a frame that is either stationary or moving at a constant velocity, constant speed in a straight line. In other words, its acceleration is exactly zero. Non-inertial frame: any frame of reference that is accelerating is a non-inertial frame. Analytical breakdown of the options. Option A: the person is stationary, V equals 0, A equals 0. This is an inertial frame. Option B: the train is traveling at a constant velocity, A equals 0. This is an inertial frame. Option C: the person is walking at a constant velocity relative to a stationary platform, A equals 0. This is also an inertial frame. Option D: the train is traveling around a bend. Even though the speed is constant, the direction of motion is continuously changing. The key to solving this question lies in correctly distinguishing between proper length and contracted length. Proper length, L0, is the length measured in a frame of reference where the object is stationary. Conversely, contracted length, L, is the length measured from a frame of reference moving relative to the object. In this scenario, the 100 m beam line is at rest relative to the laboratory, making it the proper length. On the other hand, the length measured from the moving proton's frame of reference is the contracted length. We can determine this contracted length by applying the special relativity formula. Explain how the null result of the Michelson-Morley experiment supports Einstein's special theory of relativity. 1. Deconstructing the question command. Command verb, explain. This requires more than a simple statement of facts. Students cannot just list what the Michelson-Morley experiment, MMI, was and what Einstein's theory is. They must explicitly construct a causal bridge showing how the experimental observation provides empirical validation for the theoretical postulate. Weighting: 3 marks in VCE physics marking schemes. A 3-mark explain question almost always follows a 3-step logical chain. Context a setup: what was the experiment looking for and how? Evidence: what did the experiment actually find, the null result? Connection: how does this finding validate a core premise of the new theory? 2. Chief examiner traps and student misconceptions. The examiner's comments point directly to 3 areas where even high-performing students lose marks due to a lack of precision. Trap 1. Omitting the experimental geometry, the perpendicular path. Many students treat MMI as a generic test tube experiment that just measured light. The reality: the entire premise of the interferometer relied on splitting a light beam into 2 perpendicular paths. If an ether existed, the Earth's movement through it would create an ether wind, making light travel at different speeds along the 2 arms. Rotating the apparatus should have caused a shift in the interference pattern. The fix: students must explicitly use the word perpendicular to demonstrate they understand the experimental design. Trap 2. Defining the null result poorly. The error: students frequently write, the experiment failed, or the result was 0. The fix: in physics, a null result means the expected variance was not observed. Students must explicitly define this. no difference in the speed of light was detected between the two paths, and no shift in the interference pattern occurred. Trap 3. Lazy phrasing of Einstein's second postulate. The error, writing Einstein said the speed of light is constant. Classical physics also assumes light has a constant speed in a given medium. The fix, the revolutionary nature of special relativity is its frame independence. The postulate must state that the speed of light is invariant for all observers, regardless of their relative motion, or the motion of the source. Mark 1 awarded. It explicitly identifies the unique geometric design of the experiment, perpendicular paths. This demonstrates an understanding of how the interferometer was intended to detect the ether wind, addressing the primary omission noted in the examiner's report. The Michelson-Morley experiment was designed to detect the Earth's motion through the hypothetical ether by measuring changes in the speed of light along two perpendicular paths. Mark 2 awarded. It precisely defines the null result in terms of physics parameters, no shift in the interference pattern, no difference in the speed of light, rather than using vague terms like the experiment failed. The experiment yielded a null result, meaning no shift in the interference pattern, and thus no difference in the speed of light between the two paths, could be detected, regardless of the apparatus's orientation, or the Earth's motion. Mark 3 awarded. It states Einstein's second postulate with absolute precision. By including the phrase, for all observers, regardless of their relative motion, it satisfies the strict criteria demanding frame independence, avoiding the lazy trap of just writing, the speed of light is constant. This null result directly supports Einstein's special theory of relativity, which rejects the need for an ether and postulates that the speed of light in a vacuum is constant for all observers, regardless of their relative motion, or the motion of the source. Consider the following hypothetical situation. Rachel is driving her rocket-powered vehicle along a straight test track and travels at a constant velocity between two timing points. The dashboard of Rachel's vehicle shows that the time interval is 1.000 s. Sandra is standing beside the track and measuring the time for the rocket-powered vehicle to move between the same timing points, but records a time interval of 1.010 s. Calculate Rachel's speed relative to Sandra. Give your answer as a multiple of c. The key to solving this question lies in correctly identifying the proper time, t0, and the dilated time, t. Proper time is the time interval measured in a frame of reference where the events occur at the same spatial location. Conversely, dilated time is measured from a frame of reference that is in relative motion to those events. In this scenario, Rachel is traveling inside the vehicle where the time interval is recorded, so the time measured by her dashboard clock, 1.000 s, is the proper time. On the other hand, Sandra is standing stationary beside the track watching the vehicle pass by, making her measurement, 1.010 s, the dilated time. Once these frames are established, we use the time dilation equation to calculate the Lorentz factor, which allows us to solve for Rachel's speed relative to Sandra. One, the three conceptual pillars. Inertial frames. Constant speed around a bend involves a change in direction, creating centripetal acceleration. It is a non-inertial frame. 60% cohort success. Length contraction. Proper length is measured in the frame where the object is at rest. Moving observers measure the shorter, contracted length, L. Time dilation. Proper time requires events to occur at the same spatial location, such as inside a moving vehicle. Dilated time, t, is measured from a frame in relative motion. 2. Mastering the 3-mark Explain criteria, e.g., MMI. To secure full marks on written explanations, answers must hit 3 precise points. The setup. Explicitly state the unique geometric design comparing light speed along 2 perpendicular paths. The result. Define the null result accurately as observing no shift in the interference pattern, no difference in light speed. The link. State Einstein's second postulate with absolute frame-independent precision. The speed of light is constant for all observers, regardless of their relative motion. 3. Critical examiner warnings. The gamma invariant, the Lorentz factor gamma, can never be less than 1.0. If gamma, 1, the proper and relative parameters have been swapped. Avoid lazy phrasing. Vague statements like, the experiment failed, or, the speed of light is constant, do not meet criteria and lose marks. Avoid everyday terms like steady observer, in place of standard physics terminology, observer at rest. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.